All right, so if you tried out that second question, you should see that I set it up like this, and then we ended up with 225 equals 225. So those are equal, which means that yes, right, this is a right triangle. It is a right triangle because they were equal to each other. So that's kind of our brief introduction. You're going to practice some more Pythagorean theorem tomorrow. But in order to do some more work within the Pythagorean theorem, we need to teach you how to simplify a radical. And back here, you'll notice that we just plugged that square root of 192 right there into the calculator and got 13.9. But that was an approximate answer, not an exact answer. So one of the skills that we need to develop is how to simplify square roots. When you get to Math 2, you'll do this in much more length, and you'll do it with um, cube roots and fourth roots and lots of different levels of roots. But our focus now in Math 1 is just to use square roots. So it's a pretty basic process, and what we call it is we call it the ladder method. The reason why we call it the ladder method, there are lots of different methods. So if you've seen other methods out there for doing this that you know how to use and you use them well, then go for it. But I would encourage you to use this method because we've found that it works really, really well and that it never fails. So please for at least give it a shot. So this is called the ladder method simply because of that shape ends up kind of looking like a ladder to us. And we use it to simplify the square root. So the first thing we do is we think about, well, the square root of 48. We can't take that square root. The square root of 49 is 7. The square root of 48 is a decimal, 6 point something. So what we do is we start by taking that 48 and plugging it in to the first rung or the top rung of that ladder right there. So we take that 48 and we plug it in right here. And so what this does for us is it gets the whole process started. So you have some blanks here on the left. Let's start to fill those in. So, well, I guess I got to do the process first. Once we've got that 48 there, here's basically what you do over and over and over again. It's the same process, just repeated over and over again. You look at the 48 and you ask yourself, what is the smallest number that I can divide into 48? We're going to skip 1 because 1 goes into everything. But the next smallest number that goes into 48 happens to be 2, right? So we're going to put a 2 there on the outside. Let's do that division. If we do 48 divided by 2, we end up with 24. So I'm going to put that in the next rung of the ladder. So again, all I did was I asked myself, what's the smallest number that goes into 48? The answer to that was 2, so I put that on the outside. I then did the division, and when you do 48 divided by 2, you get 24. So I put that on the next rung of the ladder, okay? And then we just repeat this process again and again and again. What's the smallest number goes into 24? It's 2 again. What's 24 divided by 2? It's 12. What's the smallest number that goes into 12? It's 2 again, right? So you will get some of this repetition sometimes. When you divide by 2, you get 6. What's the smallest number that goes into 6? Don't say 3. Smallest number goes into 6 is 2. And you get 3. And now what's the smallest number that goes into 3? The only number that goes into 3 is 3, which gives us 1. And when you get a 1 here at the end, when you get a 1 there, that means that you're done with the ladder. The ladder is now complete. So now that we've done this, why? What's the point? Well, let's come over here to the notes section and start filling this out. The first thing that we're going to do is we're going to circle any pairs of the same number. We're going to circle any pairs of the same number. So I'll give you an example. I have a pair of 2's, right? So that's a pair. And when I say the word pair, what I always consider is a pair of shoes, right? Whenever you buy a pair of shoes, you have 2 of them. You have your left foot, right foot. You wouldn't buy a pair of shoes that only has one of the feet, right? You have to have 2. So I've got a pair right there. I've got another pair of 2's. So I'll highlight or circle that pair of 2's. So that's all the pairs I have because I only have a single 3 and I only have a single 1. You're always just going to have a single 1. So you can kind of forget about him. But we circle the pairs. So that's our first step. Once we've circled the pairs, let's put a box or a square around any number that doesn't have a pair, that's by itself. So the only guy that doesn't have a pair is that 3. So I'm going to put a square around him. So we've got circles around pairs and boxes or squares around any number that doesn't have a pair. Now here's the point in doing this. We're not just doing this to annoy you guys. The point here is that any number that's circled, any pair that is circled, those numbers go on the outside of my radical. What does that mean? Well, what that means is that this circled pair of 2's way up here, so keep in mind, it is the pair, not the two 2's, but that pair of 2's goes on the outside of the radical, meaning that I'm going to write a single 2 on the outside of the radical. So let's say you went to the mall and you bought shoes, right? Let's say you bought 2 pairs of shoes at the mall. You're not going to come home and tell your brother that I bought 4 pairs of shoes or 4 shoes. No, you bought 2 pairs. So we're not going to write this twice. We're not writing it twice because it's a single pair. So this pair, this 2 represents that pair. And we do it again, right? We have another pair of shoes, this guy right here, right? This circled orange. So that pair of shoes we write with a green 2, right? Also goes on the outside. Now you'll notice that I put a dot there. The dot is there because the operation on the outside is multiplication. What we were doing to get these numbers was division. So these numbers on the outside are multiplication. Um, that's really important that you recognize that if you were to actually do 2 times 2 times 2 times 2 times 3, you would get 48. So it's still multiplication there. We were just doing division to pull out those numbers. So you'll notice that my pairs went on the outside. I had a pair of 2's and a pair of 2's again. So that's a 2 2's on the outside. But what do I do with that 3 that's boxed up? Any number that's boxed goes on the inside. So if you think about that, if for some unknown reason you lose one of your shoes and you only have your left foot, you're probably never going to be able to wear that pair of shoes again. So that pair of shoes stays on the inside, right? That pair, that lack or the lack thereof a pair, stays on the inside. That 3 can't go anywhere. He's going to have to stay inside the square root. So we've got this answer that looks kind of weird because we still need to simplify it. We still need to multiply 2 times 2 together. So when we do 2 times 2, we get 4. But then that 3 has nobody to hang out with. So that's our answer is 4 square root of 3. That's the simplified version of the square root of 48. So instead of getting a decimal, we're getting an exact answer. It's just a simplified version of a square root. And for now, the only reason we're doing it is to really make sure that we have exact numbers. The true reason we do it is for what's coming later in your mathematical career, later in high school, where you'll then actually combine those numbers with other numbers. So you've got to know who they truly are in their exact form. So we're going to try 3 examples in the next video.